In this example, we're going to compute several probabilities given this chart. The first part asks us to find what is the probability that a randomly selected baby born in this year was post-term. To do this, we need to grab two values, the number of post-term total and the total of all babies born. We divide those two values, and here is our probability. For the next part, we're asked what is the probability that a randomly selected baby born in this year weighed between 3,000 to 3,999 grams. So for this part, we're going to need the total number of babies born with that weight out of the total number of babies born in the year. Dividing those values, here we get the probability. The next part is asking us to find the probability that a randomly selected baby born in this year weighed between 3,000 to 3,999 grams and was post-term. These babies actually meet two conditions, and we can find that total number here. But notice that we're still going to divide it by the total number of babies born in the year. And when we come over here and divide that, we get the following probability. For part D, we're asked to find the probability that a randomly selected baby born in this year weighed between 3,000 to 3,999 grams or was post-term. So here we see the total number of babies born in that weight range. Here we see the total number of babies born that are post-term, but we have this number of babies who are both in that weight range and post-term. So we need to account for that by adding up these two totals and then subtracting their overlap. Again, the reason why we wanted to subtract this value is because that's the number of babies that we're counting twice when we just add up these two totals. From here, we're going to divide that total number of babies that now meets this condition in part D by the total number of babies born in the year. And you can see now that we have this probability of approximately 0.671. For part E, we're going to find what's the probability a randomly selected baby born in this year weighed less than 1,000 grams and was post-term. Notice that's a very small amount, especially when we compare to the total. The second part of this problem asks if this event is impossible. Even though that probability is very small, when we divide those two numbers there, we're going to get this really small number. It's still not an impossible event because only impossible events would have a probability equal to 0. Part F asks us what's the probability that a randomly selected baby born in this year weighed between 3,000 to 3,999 grams, given that the baby was post-term. So what that tells me, when I see this information after that phrase, given that, this is now my total number of babies. So I'm just only focused on the post-term babies, and the values that I'm looking for here are the ones that fall in this weight range. So I'm going to divide these two numbers to get that probability that's being asked for here in part F. Again, the reason we were doing that is because we were only focused on the babies that were post-term. And that was told to us because we're given that the babies were post-term. That's now like our set that we're looking from. In part G, we're asked, are the events post-term baby and weighs 3,000 to 3,999 grams independent, and why? If these two were independent, what we should see is that the two probabilities listed here would have been equal. But let's go back and look. let's look at the probability that a baby just weighs in that weight category. We found that here in Part B to be about 0.656. However, when we looked at this condition, added that given the baby was post-term, we found the probability to be different. It's 0.723, and by definition, that means that these probabilities, post-term baby, and weighs in this weight category, are not independent events.